Hello, this is Wiz Watson, and my goal is to empower you. So let's look at solving equations involving fractions and decimals. It really helps if you know operations with decimals and fractions, and you have strong multiplication skills. So let's look at the following example. In this example, it's clear that this problem would be so much easier if we didn't have these fractions. So there's a technique that I use to get rid of these fractions and leaves us with just whole numbers. Now, we have to multiply. We find a number that we can multiply each fraction by, and it will produce a whole number. So that number has to be a multiple of each 2, 4, and 12. And the best number would be the least common multiple. And as a note, it doesn't have to be the least common multiple. But we definitely want to use the least common multiple of 2, 4, and 12 because the smaller the number is, the easier it will be to handle. And one of the secrets that I use to find the least common multiple, you can choose either one of these numbers and try to find the least common multiple, but I usually pick the most difficult one and I try to find a multiple of that and compare the other ones to that. I can see right off the bat that 2, 4, and 12 all divide into 12 evenly, but if I didn't, I would list my 12 here, and I'll go 12 times 1 is 12, and I'll see that that is a common multiple of both 2 and 4. And so I found my least common multiple, LCM, already. So what I'm going to do is multiply everything times 12. I'm going to go 12 times 1/2 x, and I'm going to go plus 12 times 1/4 equals 12 times 5 over 12. Okay. So we put all of those over 1, over 1, over 1, and we cancel. We cancel so that we can get whole numbers now. So 2 goes into 2 one time, 2 goes into 12 6 times. 6 times 1, 6x. Over 1 is just 6x. Okay, same here. 4 goes into 4 one time, 4 goes into 12 3 times. 3 times 1, 3 over 1 is just 3. So that equals, same here, cancel 1, cancel 1. 5 times 1, 5 over 1 is just 5. So we see we have a new equation, 6x plus 3 equals 5. That's a lot easier to handle than what we started out with. So at this point, I suggest that you check your arithmetic and your steps before you go further. So this is an intermediate check. You don't want to go all the way to the end. I found that's a secret, that I don't want to go all the way to the end to check and find out I have it wrong. So this is a good step for me to check that I did my my cancellations and everything, my reductions right. And yes, that looks correct. So my next step is to solve for x. So I'm going to subtract 3 from both sides. I got 6x plus 3 minus 3 equals 5 minus 3. Cancel, 6x equals 2. I'm going to take this up here. So I have 6x equals 2. I can divide both top and bottom by 6. Cancel, x equals 2 over 6, which is just 1/3. I'm getting a little ahead. So 2 over 6 is just, 2 goes into 2 one time, 2 goes into 6 3 times. That's just 1/3. So feel free to pause the video and try the following example. I have minus 41 over 60 plus 7 over 20k equals 29 over 30. Okay, so once again, we want to get rid of these denominators. I'm going to pick my most difficult number, and I can see that 20 and 30 both divide into 60 evenly, and of course 60 divides into 60 evenly. So my LCM is 60. Multiply everything by 60, so I go 60 times a negative 41 over 60 plus 60 times 7 over 20k equals 60 times 29 over 30 over 1 over 1 over 1. Let's start canceling. Cancel 1, cancel 1. I just want to do this right now before you get all the way out here and then you have a big mess and you don't know what is what. So what I suggest is that once you cancel, bring it down now. So 1 times a negative 41 is a negative 41 plus cancel 1, cancel 3. 3 times 7, 21 over 1. So that's 21k equals cancel 1, cancel 2. equals 2 times 29, 58. Over 1 is just 58. So let's check that. And so yes, that looks correct. We're going to solve for k. We're going to add 41 to both sides. 41 minus 41 plus 21k equals 41 plus 58. So 21k equals 99. I'm going to bring that up. So that's 21k equals 99. Divide both top and bottom by 21. Cancel. K equals 99 over 21. 21 goes into 99 4 times. 4 times 21 is 84. So that leaves me 15 over 21 left. Okay, so we see 15 over 21, so that equals 4 and 15 over 21. We're going to cancel here because we see 3 goes into 21 7 times. 3 goes into 15 5 times. So that's going to be k equals 4 and 5/7. So feel free to pause the video and try the following example. We need to get rid of these denominators, 2, 6, and 9. We're going to find the LCM. I'm going to pick this value here. That's the most difficult value, and try to find some multiples of it that the other numbers divide into evenly. So 9 times 1 is 9. 9 times 2 is 18. 18 is my number. 2 goes in 18. 9 times 6 goes in 18. 3 times. So we're going to multiply by 18. That is our LCM. So 18 times a negative 1/2 minus 5 6. I'm going to put the 18 on the other side so that I can keep it in order, times 18. That equals 18 times 4 over 9. So let me check that and make sure that's correct. Yeah, that looks correct. And just for completeness, I'm going to group these off to make it look a little bit more organized. And oftentimes you want to group these things off with parentheses so that you can keep track of it. Otherwise it becomes a big problem, be easier to make mistakes and harder to solve the problem. Everything over 1. Everything over 1, and we can cancel. 2 goes into 2 one time. 18 9 times. I'm going to bring this down now. 9 times a negative 1 is a negative 9 over 1. It's just a negative 9. Keep track of your signs. I have 6 goes into 6 one time. Here 3 times. Negative 5 times 3. A negative 15 over 1 is a negative 15. That's what's missing. I'm missing my t. There's a t here. Put that in there. That's 9t. So that equals 1, 2. 4 times 2, 8 over 1 is just 8. So there we have it. Let me check that. And yes, that looks correct. We're going to solve for t. I have a negative 9t minus 15 plus 15 equals 8 plus 15. So I'm going to come up top. I have these two cancel. I have a negative 9t equals 23. Divide both top and bottom by the negative 9 and get that t by itself. So that's cancel. T equals negative 23 over 9. And 9 goes into 23 2 times. That's 18. Leaves me 5 over 9. Those are both prime numbers, so it can't be reduced. So the answer is t equals a negative 2 and 5 over 9. So we can use the same technique with decimals. Let's look at the following example. It looks a little challenging, but once we know the technique and use your basic skills, you should be able to work this problem. I have 3 digits behind the decimal point, so I want to multiply. It goes to the thousandth spot, so I need to multiply by that largest number, which is 1,000. This is only 2 digits. That wouldn't work because I'll still have a digit left here. So I need to multiply by that largest number, which is going to be 1,000. I'm multiplying everything now by 1,000, so I can get rid of these decimals and handle this problem. So I'm going to go 1,000 times 4.125y plus 1,000 times 6 equals 1,000 times, put this in parentheses, a negative 9.85. Okay, so that makes all of these into whole numbers. So 1,000 makes this 4,125, 4,125. 6 times 1,000 is just 6,000. And that equals 1,000 times this. This is going to give me a negative 9,850. Let me check this, make sure this is correct. So yes, that is correct. I can solve this for y. I got 4,125 y plus 6,000 minus 6,000 equals 9,850 minus 6,000. A negative 9,850 minus 6,000. These cancel. I have 4,125y equals 15,000. 9 and 6 is 15. 15,850. A negative 15,850. I can bring that up, and that's going to give me 4,125y equals a negative 15,850. Divide both by 4,125, and I'm running it through the calculator. These cancel, so y equals a negative, positive and negative. That's going to give me a negative 3.84. And I'm going to go 2 decimal places because my lowest number of decimal places was 2. I can only be significant digits to that 2 decimal places because of that. So feel free to pause the video and try the following example. I have 6.2x plus 3.7 equals 22.3. I have a maximum of 1 digit behind the decimal place. That's a 10th spot, so I'm going to multiply by 10. So I have 10 times 6.2x plus 10 times 3.7 equals 10 times 22.3. So that makes that just 62x plus 37 equals 223. Let me check that real quick. And yes, that is correct. I'm going to solve for x. I have 62x plus 37 minus 37 equals 223 minus 37. Cancel, cancel. I have 62x equals 223 minus 37. That is 186. Yeah, I think that's right. 186. Okay, so that's 186. Yeah, so we can divide both top and bottom. We can divide this by 62. 62. That cancels. X equals 186 divided by 62. That's just 3. Yeah, so I did a quick visual check on that, and that looks like it checks out. So you could either do the visual check or run it through your calculator to check your answer. It's always important to check your answer. But remember, regardless, if you check your answer, sometimes you still may not catch mistakes, but chances are on the test you still should score highly if you follow these techniques and you follow the next important step. And that next important step is you take this information and then you practice. You practice until you can do a challenging example like this one or the last one without making any mistakes. Once you do that, you should be good to go when it comes to test time. And you do the same thing the day before the test. So it's of critical importance that you practice as closely to the time that you learn a concept as possible. You don't want to wait days to practice a new concept. It starts the knowledge starts slipping away. What I do here may look a little easy while I'm doing it, and then that next day it'll look like a complete mystery. And one more thing, if you're struggling with these techniques, the problem is going to probably be go back to your basic skills: addition, subtraction, multiplication, and division. So you want to work on those. And hopefully this video was helpful to you. Please like, subscribe, share, support.